Hello, my name is Joshua Welsh, and I'll be taking you through the first official Pure Math tutorial. Now we will be starting at the very beginning at number system. Now on your screen we have the first three basic number systems. We have natural numbers, whole numbers, and integers. Now there isn't much to explain here. We started off with natural numbers. This is how natural counting from 1 to infinity. Whole numbers, we realize that 0 counts as a number. So we have a whole system now from 0 to infinity. And then we have integers, where we have from positive infinity to negative infinity. So sometimes in the book you will see people, sometimes in the book you will see, and in tests you will see people denote things like this: C plus, that's really hard to, or C negative, which basically means all positive integers and all negative integers. That's what it means. After that, we have two more. We have rational numbers. Now, this might seem a bit cumbersome to someone who hasn't done math in a while, but it's very straightforward. Their rational numbers basically are fractions and mostly for fractions. That's how we represent them. So a rational number is a number with a numerator or denominator, n numerator and denominator. M and n will, well, let me start from M and n or m numerator and denominator, where the colon in mathematics means where. M and n belong to the set or elements in the set of all integers. So that means that m and n are not fractions themselves, they're not decimals, they are integers. So they could be positive or negative. But, well, and n cannot be equal to 0, because we cannot have a fraction where m over n is equal to, well, m over n is undefined, which would happen if we had like 3 over 0, 5 over 0. We know it doesn't work out. And the highest common factor between m and n is 1. The reason why we have the highest common factor is because if we had a number like 9 over 18, that could be simplified. The highest common factor is not 1. So a rational number would be like 3 over 4, 5 over 9, so on and so on. After that, we have irrational numbers. Now, irrational numbers are numbers that cannot be represented as a fraction. So we have stuff like the square root of 2, or in fact any prime number. The square root of any prime number will give you an irrational number. Pi and the number e. Now it's denoted with the letter n, or the letter q, sorry, with a hat on top of it. That is how you know what an irrational number is. The reason why it's irrational, the names make sense when you think about it. The reason why these things are irrational is because we don't know the last digit in the square root of 2. We don't know the last digit in pi. We don't know the last digit in e. They keep going and it keeps going and it keeps going. So we just consider it irrational that a number could keep going on forever. Now, what you should see here, so let me just say that don't get confused by the C. Do not be confused by the C. The C just means C is equal to subset of. Wow. So C just means subset. So what this is saying is that all natural numbers are a subset of all whole numbers, which is a subset of all integers, which are a subset of all rational numbers, which is a subset of all real numbers. Now R is real. The name of this topic is a real number system. So basically we're learning all the real numbers in the system. So all of these numbers that you have met are real numbers, and all irrational numbers are counted as real numbers. So what we will learn from that is that basically real numbers is the union. U means union. This U means union. So that means where all rational and all irrational numbers meet. Sorry, not meet, but all rational and all irrational numbers count as real numbers. That's basically it. And so that's it for all number system. That's it for our number system, our real number system. There is another one, imaginary numbers. Those are not tested until Unit 2, so when we reach that topic, we will talk about it. But for now, this is all you need to know. Natural numbers, whole numbers, integers, rational, what did I say? Natural numbers, whole numbers, integers, rational numbers, irrational numbers, and that you need to understand that this whole equation here. And right, don't need to understand it, because this topic is rarely ever brought in an exam in any way. It's really just to appreciate that all natural numbers are all whole numbers, which are all integers, which are all rational numbers, which are all real numbers. And if you're wondering how could like a whole number be represented as a rational number, it's because 3/1 is a rational number, but it's also a whole number. So let me get that in the screen, kind of didn't fit. Yes, so that's it. So 3/1 is equal to Q, which is equal to W, which means, so they're all within each other. And I hope that helps. I will drop another video soon, and stay tuned until the next one.